Class 2, lecture 26, continuing with polar coordinates. So, I had the r equals 2 cosine theta, and it was like this nice circle located at this point with center at 1, 0. So what do you think r equals 2 sine theta is? Well, it's like this, except it is this way. Again, the point is 0 in this case. So, functions like this with sine and cosine, not sine 2 theta or n theta, I will tell you what they are. These are in fact circles. So let me give you the general form of these. So r equals, say, a cosine theta is either this, and it is at a over 2, 0, when a is bigger than 0, or it is this, minus a over 2, 0, or let's say if when a is negative, not minus. Okay, so this is cosine, and r equals a sine theta, as you can guess, like this. So let me just draw one. That's okay. So let me draw two pictures. Okay. So it is at point 0 and a over 2 when a is positive, and it is below the x-axis. Below the x-axis, and that is again 0 and a over 2, a is negative. So the four circles, they are tangent to either x or y-axis. So cosine is to right and left, and sine is up and down. So these are circles. There's another type of circle which is this. R equals a constant. R equals a constant is like y equals a constant. So R equals a constant, C, constant, and that is in fact a circle with radius C. So this is 0, 0, and this is a circle with radius C. Okay. There are other types of circle, like if this O is somewhere else, then you will get other formulas, which I leave that to you. Now, there are lots and lots of other things. So I'm just give you another, and it's R equals, say, a cosine n theta, and R equals a sine n theta. And these are roses for n bigger than equal to 2. So these are roses, and so when you have, say, 3, for example, when you have 2, you will get 5. Sorry, 4. So I think so. So anyway, you will get the roses like this. So I again leave that to you. Maybe I give you a demonstration of that on mathematical. So you will get a rose like this. Or if it is cosine will give you something like this, and sine will give you something else. But it's rose. It's just rotated. So you might get a rose with 4 petals like this. And so on. So these are roses when n is bigger than. That's why I said in the other one that it should be just theta, not 2 or 3 theta, because then you will get roses. And some other things. You can check the textbook for other types. Now, one thing is, I mean, other nice pictures that come out of this. So one thing is that I should, how to convert from r theta to xy. This is easy. And convert from xy into r theta. No, it's not easy now. This one is easy. So how do you do that? So if I have, say, examples, let's take r equals to cosine theta. These examples, there is no general rule for this one. It's just your expertise in dealing with formulas in trigonometry and algebra. So what can I do? In this situation, I can multiply both sides by r. It's not always like that, so don't say I said that. No. If I multiply by r, I will get r squared is 2r cosine theta. R squared I know is x squared plus y squared, and r cosine is y. Remember, this is y, and this is x squared plus y squared. So I have this. You can just leave it like this and say, that's it. That is the formula, the rectangular formula. But we can put it in a much nicer way. So let's say x squared plus y squared minus 2y plus 1 equals 1. So I bring it here to this side and add a 1. And then I have x squared plus y minus 1 squared equals 1. Okay, so what is it? It is a circle centered at, no, that's x in fact, CDG. I'm saying what goes around. This is x, not y. R cosine is x. So this is 2x. So I have x squared minus 2x plus 1 plus y squared equals 1. The same thing happens here. So I have x minus 1 squared plus y squared is 1. And that is a circle with center 1, 0 and radius 1. Okay, so that's how you do it. You multiply in this situation by r. It's not always like that, please. Now for the other one, for roses, well, let me give you, let's write a rose here and see if I can come up with something with the rose. So if I have, say, 6, say something, cosine 3 theta. If I multiply by r, I will get this thing, then 6 r cosine 3 theta. This is x squared plus y squared equals 6 what? R cosine 3 theta, I can write cosine 3 theta in terms of theta. There is a formula, but that formula involves cosine to the power 3 or sine to the power 3. What is it? I mean, r times that. So you won't get anything nice here. So it's better to stick with the polar. Stick with polar. Okay. So in this case, don't try. Now another thing is lines. What are lines? First of all, let me go from xy to examples where that was 2 or 3, say. Say xy to r theta. So say you have x3 plus y3 equals 1. Then you want to write down polar form. It's very simple. X is what? R cosine theta to the power 3, r sine theta to the power 3 equals 1. Okay, that's fantastic. So I have r3 times cosine 3 theta plus sine 3 theta equals 1. Finished. Well, this is a nice and legit polar form equation. It's not a function. It can be a function because we have R3. What is the relation between R and theta? And you just do it. So for x and y, if you have the rectangular form, you can simply write r cosine and r sine for x and y, and that's it. You have a relation between r and theta. That's why I said this one is much simpler. The other one is not easy. So let's see, another example is example of lines. So let's say number 4, lines. So what is the general form of line? I have ax plus by equals c, right? And this is if a, b are not 0, and c also, let's say c is not 0. So none of them is 0. Now, if I write a r cosine theta plus b r sine theta equals c, and solve for r will be c over a cosine theta plus a sine theta. So this line has this interesting and nice polar form. So line has this polar form, which is a nice formula. It's not as simple as r equals a constant. Remember, r constant gives me this circle. This circle in rectangular form is x squared plus y squared equals something c squared. But in polar is simply r equals c. Finished. Boom. So now this one is a simple equation in xy, say in xy. This is not simple. This is sine and cosine. It's in the denominator, and sine and cosine are transcendental functions. This is where you don't even see x squared here. So you see the polar form of this simple line is a lot more complicated than way more advanced, say, than the line itself the line in rectangular form. So what are the other cases? So this is the first case. Now what if I have a case like this? So B is if I have y equals a constant. If I have y equals a constant, then this is in fact, and this c is not 0, so let's assume c is not 0, and this is r sine theta is c, so this is c over sine theta, okay? So that is horizontal line, that is horizontal line, and vertical line is this. So C, if I have x equals constant, again C is not 0. So I have r cosine theta is c, and r is c over cosine theta. Now, once I ask my students to draw a vertical line on their calculator, and nobody was able to do that because they were using rectangular coordinates. If you use rectangular coordinates, you cannot draw a vertical line because this is not a function, x equals 0. But you can draw it using polar coordinates, and you will get an amazingly nice vertical line. So, anyways, so what is the third one? The third one is something like this. So let me, and the fourth one. So that was vertical line, and D is a line like this. What is ax plus by equal to 0? This gives me y equals minus a over b x. So what is this? If I write r sine theta equals minus a over b r cosine theta, and assuming that cosine theta is not 0, and the r's cancel out. Just look, there is no r. So that gives me tangent theta is minus a over b. And there's no r. So what is this? This just tells me that theta is something. Theta is tan inverse of minus a over b. And theta tan inverse is in fact this line, one of them, depending on the situation. A and b, positive or negative, you will get something like this. So this is in fact the line theta constant line. And remember, theta constant line cannot be put into function form. The same way that x equals to constant in rectangular coordinates cannot be put in function form, theta equals constant cannot be put in function form. It's not r equals anything, nothing. Or the other one is not y equals fx, there is no y equals anything for vertical line. So this is like, we started with this. We said this is in fact the, say, independent variable. So those are in fact equations for lines, and you can use them if you're asked to draw a line in a polar form. Okay, now what is tangents? First of all, writing parametric equations. Parametric equations for a curve given its polar form. So we are given r equals f theta. Well, let theta be the parameter. The parameter doesn't have to be time, it just can be anything. So let theta be the parameter. Remember, we have x is r cosine theta and y is r sine theta. So this gives me x is f theta cosine. F theta cosine theta and y is and so theta is the parameter. So using the polar form, I can come up with parametric equations for the curve. And the parameter here is theta. Let me give you an example, say, and then well, let's take that r equals, what was that, 2 cosine theta, that's polar, and then x equals 2 cosine theta, and y is 2 sine theta, no, what sine? Cosine theta, sine theta, again, this is parametric. And in this situation, I just say theta goes from 0 to pi. Now, I didn't discuss this thing. We just, for this one, remember, we just needed from 0 to pi to have the whole circle. We didn't need 0 to 2 pi. That is, in fact, one big problem with, not problem, but something that you should be careful when you are dealing with polar coordinates. So you don't need the whole pi. The whole pi in this situation will give you twice. So if I let, in this situation, if the theta goes from 0 to 2 pi, then I will get this circle. 1, G. It starts at 0, so if I choose this, it goes like this: 1 turn, 2 turns. 1, 2. If you are finding the area of this thing or arc length or anything, you will get twice. You will get twice the result. So, I mean, whatever that is. So, be careful. For polar, I will discuss it when it comes to finding area specifically. That's perhaps the next lecture. So, how do we find? So, writing a parametric equation for a curve given its polar form is very simple. Use r equals f theta in x equals r cosine theta and y equals r sine theta. So, if I have r equals f theta, finding a formula for tangent line, for a line tangent to the curve at theta equals some theta 1, or the point is given. In rectangle. xy. If it's given in rectangular form, we should find theta. We need the theta. So, let's try to find, first thing we should find is slope of tangent line, right? We need slope of tangent line. So, slope of tangent line. Remember, m as a function of theta in this situation is d y d theta over dx d theta. So that is d by d theta of, remember that was f theta, y was sine theta, right? And this was d theta, and that was f theta cosine theta, right? That was dx. So that is the derivative of this one times this one, that's f prime, I just write prime, which means with respect to theta, sine theta, plus the derivative of this one times this one, it is simply f theta cosine theta. The denominator f prime theta, that's minus, that is cosine theta, and this one is minus. The derivative of this is minus sine, so it is f theta sine theta. Okay, you can leave it like this. Some people divide this by, I don't know, maybe cosine theta, and they will get tangent here and tangent here, and well, this is okay. Why should we change this thing? I think that maybe the book has a much nicer form for this thing, but it doesn't make any difference. So that is in fact slope as a function of theta. So if you are given theta, you can find slope, and having the point, you can find the point in fact. If you have theta and the formula, you can find the point in xy coordinates. Then using that, you can write down the equation for tangent line in rectangular coordinates. Okay, so let me give you an example. Find an equation cotangent to r equals, say, 4 cosine theta at the point where theta equals pi over 3. Okay? I guess more than makes sense. So I have picture that picture here, so I leave this side open. So this is in fact my circle. Center is a over 2, so this is in fact 2, 0. And the radius is also 2. So this is pi over 3, this is this point. So it should be, I don't know, it should be like this, I guess. So I'm trying to find the slope of this tangent line. So m theta is, first of all, let's write the equation in, I think I wrote that for you. Let's do it again. So I have x is 4 cosine theta, and y is 4 cosine theta, sine theta. And the theta goes from 0 to pi. Okay, so I need dy, dx d theta, and look at it, this is cosine square theta. And this one is 2 sine 2 theta, right? So let me, you need to remind yourself of some formulas and trick formulas. So I don't have enough space here, so let me erase this and do it here. Okay, so m theta was what? F prime. Now f prime cosine theta. No, f prime sine theta. What was that? Let me do it again. So it's well, I have it here. Why not do this thing? It's dy d theta over dx d theta. When I have it, I don't just go back to formulas. And so dy d theta is this, and I have 2 is 4 cosine 2 theta. This one will be, dx d theta will be 8. No, where does this come from? That's correct. So 8. The derivative of this is times minus sine theta cosine theta. So that is in fact 4 cosine 2 theta, and the denominator is in fact 4 minus 4 sine 2 theta. Okay, so it is in fact minus cotangent 2 theta. Let me double check because this one will be cosine, that is 4 cosine 2 theta, the other one is 1. Now at theta equals pi over 3, so m of pi over 3 will be minus cotangent of 2 pi over 3. That is, I don't know what cotangent of this thing is, so let's write it. So that is cosine 2 pi over 3 divided by sine 2 pi over 3 minus cosine 2 pi over 3 is this thing, and that is pi over 3 cosine of pi over 3 is 1/2, right? So that is minus 1/2 that is square root of 3 over 2. So this will be simply 1 over square root of 3. Well, that's minus cotangent, so it should be cosine, I think so. Well, anyway, so let me double check in my mind that cosine of power. That is cosine of this thing. And that cosine is in fact 1/2. Yeah. But anyway, so check my calculations. But anyway, so that means this thing has a slope 1 over square root of 3, and how to find equation of the line. I need this point. Coordinates of this point. Coordinate of this point. The coordinate of this point is so I have m. So let me erase this. I found m to be 1 over square root of 3. Let me write it here. So I found m to be 1 over square root of 3. Now the point is r theta, and the rectangular form will be this thing. So if theta is pi over 3, x will be 4 cosine squared of pi over 3. Cosine squared of pi over 3 is 1/2 squared, and the y is 2 sine of 2 pi. Sine of 2 pi over 3, that is a sine squared of 3 over 2 squared. Is it? I think so. So that's the x, and the y, if I'm correct, let me double check, that is pi over 3, so x is 1, yeah, that's 1, and y is 3. Y is 3. So x is 1, and y will be 3 over to 1.5. So the equation of the line tangent 1.5 equals 1 over square root of 3 times x minus 1. Something like that. So that's how you do it, and I'm just going through this so fast. Check the calculation. It seems to be okay because the y coordinate seems to be okay, and then this is 2. Yeah, makes sense. So that's it. So y minus y0, x minus x0 times m. Okay. So that is the equation of the line. You can simplify this. You can leave it like this. That's okay. So that was how you find line tangent to a polar curve. Now next time I will discuss area and arc length. That area is perhaps sometimes confusing, and that is because of the fact that I said when you go from 0 to 2 pi, for example, you might be going through the curve twice, or who knows how many times you are going through the curve. So it is important to graph the polar curve before you do anything, especially when you're finding area. So that area needs one full lecture, and I will do it next time. Okay, so have fun.